is this model in the program already, so they can just open it in their programs if they need. So
yeah, sure.
I will create new cell. But first I will add manipulator. I just will create one folder in the library to save all objects there, because I already saved them correctly earlier and I don't need to repeat it. Now the models were added. Now we need to move them. First, I will set manipulator on the pedestal. So to do so, I need this button, relocate. Now I choose 2 points to define frame of relocation. I will also set another frame in here. Now I will move it also. Now I will attach the gripper. Now I will model the movement of the welding table. I don't know how exactly this thing called.
Yeah, this rotating table. Oh, you can't say it.
So to do so, now it can't move, but we should add 2 degrees of freedom to this model. So at first we go to set model in scope. Then we go to kinematics editor. We choose model and click create link. Name of this link, it will be base. Then this, it will be amp. This one will be plate. Now we need to add connections between them. First I will hide this. Just put the arrow. We add the frame to the center of this circle. Then we choose this frame. We again choose this frame and just add some distance here. We set the limits and
Yeah, actually, this approach is really very useful if you have to model the robot from scratch. You know, if you have your model, that means you don't have any XML attached files. So you have to follow this procedure in order to create the kinematics chain of the robot. So it's really very useful. And yeah, thank you very much for this presentation.
For example, if you download model in step format and just have like parts which are not connected, so you can define connection like that.
Yeah.
We also set frame here. After we finish modeling, we just press end modeling. One second.
Just delete this editor.
Now I will try to move it. You can see that it can move. All 2 degrees of freedom. Now we will attach piece for welding to the welding table. Do so, I press relocate, choose frame between 2 points. And choose the center of the circle here. Now we need to attach the welding part to the plate of the rotating table. So I click attach and to this object, press OK. Now, if we go to the join jog, oh, no, it doesn't work. Strange. Yeah, we need to attach welding pad to the plate, exactly, not to the welding table completely. So now pad rotates along with plate of the table. We can also add additional 2 degrees of freedom of the table to the manipulator. To do so, we go to the configuration properties, robot properties, external axes, add, select our rotating table and choose degree of freedom. Now if we will go to the robot jog, we will see that now it has 2 external degrees of freedom. They have special letter E, but now we can move it here.
Yeah, actually, the same is true in the real robot. Actually, we have a KUKA jet in our lab, and we have this rotating table with the external axis. So we can control the external axis and the robot together from the teach pendant. So the same is true actually in the real application as well. So that's...
Now I will try to simulate process of welding. To do so, I go to process, continuous process generator. And select base, and after that site set, and just press triangle. Doesn't work. It doesn't work automatically.
You have to click it. Click and then it will add. It will increase. I think. Just click again on it.
Now it should faces like exact. There are some kind of mistake. Strange. Okay. Probably when resaving the model, exact geometry was corrupted. So yeah, it's not a big problem, but it's better to use models from the library of the program, because I just exported them and exact geometry was damaged, I suppose, because I didn't click to save it. But for now, it's not a problem. We can choose it by hand. Oh, yeah. So I probably need to delete this model and now we go to continuous process generator. Select base. Yeah, now it works. And we just press this triangle and it automatically adds another surfaces. that, we press project Axim. Here we can choose parameters of welding torch of different angles and press project.
Yeah, actually, here the point is the welding torch can make collision with the product, so it's always necessary to have the angle of this torch in order to avoid any collision and yeah, any damage to the product. So that's useful.
Yeah, it works. I think it was colliding with the part. But it can be adjusted, so it's not a big problem.
Yeah, can you make maybe just very fine because it is a little bit far of the discrete, the points, the intermediate points between.
Yeah, I
We
can
can
do
also
that.
increase.
To check collision, we go to collision, new collision set. Just select our manipulator, our welding torch, and here we can select
The model one.
also we can show this in colors too if you press this button. Collision options, sample stop simulation, and we need to switch collision mode on. So we go again. We see that there is a collision. For example, we can add position, add location before. And also we can add start position. Which will be just 0 position. Yeah, here is collision again. But this one I will not correct because at first I will try to add another welding operation, for example, with inner surface. For example, this surface. I'm not sure why it doesn't work. Strange, it gives, somehow it doesn't choose.
Yeah, actually.
Maybe I will try to choose. So, yeah, we just needed to remove set current operation because somehow it gives some kind of mistake. I don't know. But now it can, the path can be created. So it's another operation. We press project arcsim, project, close. Now we can move this operation to first one. We can delete this. I will switch off collision mode for now. Yeah, it moves somehow. Also, we can modify speed, sample. And for these operations, we go to set locations properties and set speed to 20 millimeters, maybe. And also here. Yeah, we see the collision and see that it rotates. But there is another feature, arc continuous positioning. I suppose it's created to place welding gun in one position, so we can rotate the table, but we try to keep position of welding touch in one position. So we choose this operation. Positioner is added automatically. And for example, we choose 7-degree angle, press apply, and try to simulate this now. Now the table is rotating. Yeah, There is a collision, but it's not a big one. We can see that welding gun is trying to keep this position and table just moves. I suppose it gives better quality of welding. Yeah, there are some small collisions, but I don't think that's a problem for now. Yeah, I think that's all from me, at least.
Yeah, that's very nice. And one point is, can we see the motion profiles from the velocity, from the acceleration, and so on? Then we can see how the motion of the motor behaves, maybe from the.
No, I only know that we can set speed parameters and acceleration parameters, but I'm not sure that we can see some kinds of graphs.
We can see it in the, just click on the robot.
Yes.
Then in the menu, from the menu bar, we click on the robot from the menu bar. Yeah, okay. So here we can go to the, for example, robot viewer. Here, for example, we can, from the panel, we can select actually whatever we like.
Oh.
I personally would like to see the TCP. The TCP is also possible. We can see also the joint variables. So you have to play it to see it here, right? So the TCP, the motor at the TCP is only rotated at the very beginning. There was a motion, but then after it was constant, zero. So there is no motion on the TCP. That this implies that, right? So the speed of TCP is constant, zero. It's only just now it's already changing. When it changes the orientation, then it changes. Then it will keep the orientation as it is. So it's not TCP who is moving, it is the other body parts, instead of TCP, the rotating table as well as the other, it's a rotating table. So, so here, you have to make a compromise. Actually, either is it good to move the robot body or the table, this external axis or something, Yeah, just regarding the job efficiency, the power, the speed, and so on. I think this external access is really nice because it minimizes, the robots dynamics. The robot dynamics is not being heavily affected here because the external table is rotating by external force, by external controllers, so it doesn't affect the dynamics of the robots. That's a good part.
Yeah, it's also written here that welding results are best when seams are parallel to the floor, so it's like gives better quality of welding if you use the table, I think, because it can orient the part.
Yeah, actually, yeah, one point is now we have a line, a continuous line, but the other question is what if we have a surface instead of a line?
Oh,
for example, in case of painting or in case of painting, for example, or
yeah, I think it's also done through the continuous process generator, but for now I'm not like 100% sure. Oh, yeah, this one has some coverage pattern. Yeah.
Yeah, definitely, exactly. This is it. So instead of a line, this will make iterative strokes to and from. So the distance between the stroke or the spacing of the strokes will decide about your welding coverage. So how far you can cover by one spray paint. So you decide about your spacing, then about the strokes, length, and so on. Then yeah, everything is fine. So you will specify the initial point, then the end point, then the spacing, then it will generate stroke lines between the initial and the final points. Yeah, either vertically or horizontally. Yeah, so these are actually if you have operation which looks like a welding, then you use a welding operation process. If you have an area like painting, like where you have to maybe like debarring operation, something like this, maybe you can use the spacing, the coverage pattern. So that's all about actually. Then the rest, yeah, you can try by yourself. So this is yeah, good enough for today from Ruslan. Maybe is there any question? Maybe if you have any question, maybe here on this approach, maybe we can discuss together. Is there any question from the students? I give you now the chance. Just you can talk. Just if there's any question, or maybe if you have any other suggestion or something like that, or maybe if you have again also additional ideas that we didn't cover here, yeah, you are welcome. Yeah, from next week we do the tutorial in the mathematics. So we will do the mathematics, how to compute the kinematics. We have seen, how to generate the reference frames, how to connect the already show us how to connect the different models with the different kinematics. But now the point is, how do we apply the same with the mathematics? So we will see this next week. So we do some yeah, exercise, practical exercise. Yeah, so regarding the geometric modeling and the simulation, this is all about. So we finalize it here. Thank you very much, Islam. Thank you very much. You explained it very well, and yeah, this in depth as well. So thank you.
I also,
yeah. Who is talking? Yeah, questions will come.
Yeah, actually, yeah. Hi, Mr. Tully. First of all, thanks, Ruslan, for this wonderful demonstration. I have also tried to weld a kind of cylindrical surface upon a base plate. Now, you have one complex contour. Circular contour is also complex in case of avoiding collisions and something like that. So I tried it. The thing is, I tried it even though I'm having collisions, but I think there is an option in the process that's called as split seam operation. So I was wondering, I didn't have quite, yeah, not that one, below of that, yeah. Even though I didn't have a quite amount of time to explore this option, but I think this is what we can do in case of avoiding collision for complex contour. Suppose if I want to weld a circular section or the cylindrical contour upon a base plate, then it becomes quite hard. If we follow this type of process, because anyway, one way or other, you encounter a collision. So
yeah,
I was wondering.
I didn't try this one, but I think, yeah, we can split the sim operation and then just add maybe some additional points for manipulator to move. So yeah, we can maybe do it like that. For example, like here, I added additional points, and during operation, maybe, yeah, we can split the sim, and between these new sims at another point or something like that. I'm also didn't like went to details of these all operations here, but I think here it's something like that.
Yeah, okay. I'll also try to explore this. And I have one fundamental question. That is, so I have saved all of these operations and other things, but the thing is how exactly I can invoke the previous operations and other things which is comprised in a single file. Like for me, it's getting dismantled all over again.
The fact is you need to save it to the right location, because or maybe the library is I will show. For example, open. Yes. The fact is you just need to choose right library, because there is one library which goes from the program itself, and there is one library that you made. And when you open your model, you should choose correct library. So probably the problem is with library settings, because if it works correctly, you just save the cell, and after that you just open it and it works.
Okay, so do I have to open all the parts by parts, like?
No, you don't have to open it.
Okay.
Yeah,
if you
the point is, when you create your when you open your study, you have to specify the root location, of your system file, where you already located all your libraries. You know, you have a project folder and you have a system folder. You know, where you created your project.psd or something like this, and you have library where you have the JT files and so on. Now the point is, whenever you start, you have to set the root folder into the system folder where you have all your libraries, your CID models and so on. Otherwise, it will tell you there's a miss or maybe a disconnect or something files.
Yeah, for example, I open this cell and there are some problems with my manipulator model in the library because I saved it wrongly. Other parts are opened, but manipulator is missing. So if it was saved correctly, manipulator will be here, but other parts now, for example, are here. And 1 second, I want to show another thing. Can you see my screen now? Okay, no.
No.
Oh, I don't know how to show. Can you see like the welcome screen or no?
Yeah, I can.
Yes.
I also want to mention that there are tutorial session, because what I did today explained in the tutorials of the program, and also it has already created cell, ArcWeld example. And when you open it, it asks to change the library location. So you need to click yes, and now the library is switched to the library of the program initial one. And when you return to your own models, you should choose again yes and return to your own library. So it was already created in here, and it has, and you can copy that. For example, it has more difficult operation, like it's more interesting, yeah. But your problem is in the setting of the library.
So
Yeah.
is it also true that we should always save our project inside somewhere, inside one folder where already library is there or something like that? Or
I have something like that. I have a Robot Expert folder, and I have cells folder and library folder. Actually, this one is wrong because I saved it to the library itself, but as in example, and in tutorial, you have cut folder when you can save different 3D models. You have parts folder where you can save your parts, and you have resources folder where you save, for example, robots, weld torches, pedestals. But it's again explained in tutorial video how to create correctly your library. So it's better explained there because.
yeah, okay, I understand.
And when you just input your parts, you just, at first you, for example, select, and after that you should specify where you will save. You should save your model to correct locations. For example, if it's, I don't know, welding torch, you just need to save it to the resources file touches. And yeah, and choose correct classes.
Yeah, clear right now. Yeah.
Yeah. Okay. Thank you very much, Ruslan. And yeah, so we finalized here. There's no